So you upgraded to the 48 or the 24 volt system, and now you're worried about your 12 volt devices not working anymore. Well, I'm here to tell you, you can keep all your 12 volt devices and you can throw out your battery and you can throw out your converter. There's a very easy solution to these, and I will walk you step by step through each of the devices. And at the end, I have two use case scenarios of how I implemented these, one in my fifth wheel and one in my food truck, and it'll show you how you can implement them and solve this problem and never buy another 12 volt battery again. So I've broken this down into three sections, and there's three possible solutions, and sometimes even a combination of those solutions that I feel is important. Those three categories are: keep a battery, use the existing converter, not to be confused with the inverter that you use on a solar system, the converter in your RV or trailer, and I'll tell you about a little bit more about that. And then a step-down device, which takes the 48 volt and brings it down to 12 volt. There's pitfalls to each one of them, and there's probably a solution in here for you. Let's talk about the battery first of all. So the battery comes with the biggest problem that you're going to run into is that you're going to still need to charge this battery. Now, if you have a 12 volt battery and a 48 volt solar system and 120 volt normal power, the last thing you want to do is to have to charge this solar and charge this battery and maintain a 120 volt. And this is the problem that we're all dealing with, because most RVs are built for 12 volt operation. Now, that said, that's what we're here to figure out a solution around and see if we can come up with a way to deal with this without it being too much of a hassle on our part. You could go with a 12 volt solar system, but then you run into the obvious problems that come with that of charge controllers being more expensive, cables being more expensive, everything being more difficult, being able to provide enough power, being able to run air conditioners on it. Anything with large quantities of voltage going through your 120 volt system becomes an issue, because then you have to have cables that are so big and so on and so forth. So maintaining is the part where you have to buy it. You have to deal with connecting it. You have to deal with making sure that it has a charger hooked up. You have to make sure that it has all of the if it's a lead acid, you have to make sure, if it's if it's lead acid, you have to put water in it. You have to do all of the stuff that's around this. If it's a lithium iron phosphate battery, then you have to deal with what are those systems that you currently have that have to be replaced. So you could upgrade to a LifePod battery, but then that creates new problems. Now, those new problems, in my mind, are better than leaving the old battery in its place. But they're not necessarily, do they eliminate all the other things? You still have to worry about charging it. You still have to worry about keeping it connected. You still have to worry about that. But if you're looking at a limited use case where you only have a few lights and stuff like that, there's probably a better option. If you're looking at, you need that surge, and we'll really get into surge when we get down to the step-down devices. If you really need that surge, then you're going to want to look at possibly doing this solution, because this allows that influx of large amount of power, but you don't need it constantly in order to run your system. In other words, if you have just a couple of lights in your RV, but you also have stabilizers, you'll need it when the stabilizers are running. They pull a lot of amperage, but then you won't need it to run the lights. So a battery in the middle solves that problem where it allows you to flex up when you need to. The LifePod 4 battery allows you to not have to worry about killing it and charging it and all of that stuff as much as you would a regular lead acid battery or some other type of battery. So it's just the maintenance on these is a lot easier and that kind of stuff. So that's one option. The next one is your charge inverter. Now, most RVs in them that takes step down from 120 AC power and brings it into 12 volt DC power. Now, the size of this step down is very dependent upon your RV. In my fifth wheel, it had a 55 amp, 12 volt, 55 amp in my RV. So that's rather large. A lot of the smaller ones only have a 20 amp or a 30 amp, and it just really depends. And the only way to really know is, in most cases, behind your panel in your RV, you will find a step-down device, and sometimes just a little pop-out piece, a step-down device. And on that converter, not step-down device, on that converter, you will notice that it has a rating here where it takes the 120 and that. Now let's talk about the pitfalls to this. The biggest pitfall is it requires 120 volts. That means you have to be plugged into shore power, or you have to have a solar system that's actively running in order to run this, in order to charge this, and then you have the inefficiencies of taking AC power, converting it to DC power, taking DC power and putting it into a battery, and then taking it back out of the battery and converting it back. So this has a lot of, it requires the 120 and it has a lot of inefficiencies with it, but it is a viable solution if you're not worried about having, if you have shore power all the time and you just have solar to allow you to run off grid sometimes. Depending on how much you need this can be a viable option. The one of the biggest problems here means that if you don't have 120 power, then you aren't charging over here and you aren't maintaining this 12 volt, and you don't have the 12 volt power available at all. So this can be used to run everything or to charge the 12 volt. Now, it's a trickle charge, and so it's not going to be a fast charge. You're not going to be able to just hook it up and an hour later it be done. It's going to need to be plugged in a majority of the time. It'll take what it needs. It'll help assist the DC power on the 12 volt side over here so that it can handle the surges and stuff like that. So in some cases, in my case, I could remove the 12 volt battery as long as I had 120 power running. Now, with option 3, the step-down devices, there are a ton of different ones, and they all have ups and downsides. There are some cheap ones out on Amazon, and I'll include a little picture of one of them. But you got like a 10 amp one, a 20 amp one, and a 30 amp one that I've seen. And these all run somewhere between 15, probably 15, around 15 for that one, and around $28, $30 for this one. These step-down devices they're little square devices, have a couple of wires coming out here, a couple of wires going out there. Your 48 volt goes in one side and your 12 volt comes out the other. Very, very straightforward, very simple, small little metal things with basically look like giant heat sinks. If you have simple lights and nothing more, they're fantastic. If you have anything with a surge, if you have rollouts, if you have leveling system, if you have any computer equipment that runs on that, like my leveling system ran my leveling system runs on a computer, and it would start up with these and then die out. Now, that said, I installed 5 of these, giving me a total of 150 12 volt amps. And it was not enough to handle the surge. It could not surge up to 30, 35, 40 amps to get those rollouts running and still provide enough power to keep the computer on. It would, the electricity, the power, the voltage would drop far enough where the computer would shut off. There are a variety of these. There is another section of these in the middle of the road, the mid-range. The mid-range ones of these run for anywhere from 20 to, I've seen them out there for as much as 150, maybe even a little bit more. There is a whole variety of these. I have not tried them. I am assuming that some of them will work just fine. Some of them will be able to handle the surge. Some of them won't. Then there is the third one, which is the one I went with because I trusted it, which was the Victron Orion. And it's basically 30 amps of 12 volt. I installed one of these at first, and it would start my slides. They were sluggish and all of that. Everything else was flawless. Lights, that computer wouldn't reboot. Everything else was good. After I installed two of these, that bring me to 60 amps. I don't even know that I originally had a 12 volt system. I basically have converted, got rid of the 12 volt battery. Everything from this side is completely gone, and I only use this side for 12 volt. It plugs directly into my 48 volt system, and it takes care of all of my 12 volt solutions. So this is from one extreme of using a battery, possibly having a charger or a separate solar panel to maintain this battery, because really in reality you don't need a whole lot here, to a converter taking care of it or running your system. And then the third extreme is going 100% with a Victron Orion 48 30 12. And depending upon your RV, I would say make sure that this matches this, because this is designed to make sure that your system has enough power to operate without relying on this battery. And if you can have enough amperage here within this Victron Orion, you should have enough amperage to run your entire 12 volt side of your system without problems. I'm pretty sure that these are sold in different types. They also make, in the converter category, they also make a Victron step down device that is specifically designed for stepping down power and charging a battery as opposed to just offering power to it. Please keep in mind that the Victron Orion is not the smart device. The smart device is not only made for stepping it down and giving you power, it's for stepping it down and charging. So if you go with the Victron Orion, I think it's Orion Smart, then not only can you provide the electricity, but you can also charge back to the battery and maintain it. I did not look at that case very much.
Glad you could make it to the bonus section where we have two excellent use cases. Both of these are real use cases from my real equipment that's installed, and how you can eliminate your 12 volt battery with either your 24 or your 48 volt solar system batteries. So let's move on and get going. On the next section, you basically have the first section here is the grid power comes in, and when the grid power is going to connect, and this is the existing setup in my fifth wheel, so I'm talking about how it's currently hooked up, and then I'll show you the next slide exactly how it's been changed. This grid connects to, when you plug in the grid, it connects to the converter. The converter, not to be confused with the inverter in a solar system, which takes the 12 volt battery or a 24 volt or a 48 volt battery and converts it into AC power that you can use as an outlet. This one is exactly the opposite. The converter takes the power from an outlet and uses it to replace your 12 volt power, gives you electricity so that you can run the 12 volt systems. In addition to that, it also trickle charges your 12 volt battery so that if you've used it, then you can replace it, and you can replace that power and have it charged up. So moving on to the next section, this in turn obviously feeds into your battery, and then your devices are connected to this. And I have simplified these charts so that they make very easy, can demonstrate how these devices are hooked up. Please keep in mind that in real systems you would probably have items like bus bars and fuse boxes and circuit breakers and stuff, but the exact flow of the electricity is accurate here in this description. You just have to figure out what pieces are in between each one of these. All right, now let's take a look at how the fifth wheel use case changed the setup in it. So for the change, the idea here is to completely eliminate the 12 volt battery from the system and any components that relate to it. So what we basically did is we installed a 48 volt or 51.2 volt lithium iron phosphate solar system with a 6000 XP inverter. This I had three of these batteries hooked up, and my thinking is there was no reason for me to maintain a 12 volt system when I had more battery power here than any amount of 12 volt batteries that I could put into that system would ever be able to maintain. So what I did is I took this 48 volt battery and ran it into the device called the Orion TR 48 12 volt 30 amps. So basically what this means is it inputs 48 volts, it outputs 12 volts, and it outputs 430 amps. Now in my real case, I needed two of these devices to allow me to control all the equipment in my RV without any problems. One of them ran everything worked, but there was some sluggishness when it came to leveling that I wasn't really particularly happy with, so I put a second one in. The idle consumption on these is about 2 to 4 watts. It's very low, so I just leave them on all the time and don't even bother shutting them off, and they both just run constantly. Theoretically, I only need one of these most of all the time, and then I only need the second one when I'm doing leveling or something of that nature, but I don't bother to mess with that. This obviously feeds out into the same location for running devices as the original system. I take these wires, run them straight to the bus bars, which powers the entire RV, goes to the breaker box where there's fuses and everything. It takes care of all of that stuff. So nothing has really changed here, with the exception of I did eliminate the converter because there is no reason to have a converter here taking shore power, which would be generated from the 6000 XP, converting that to AC, that AC being the inverter converting it to 120, the 120 converting it back to 12 volt, and the 12 volt going back into the RV. So I basically eliminated all of that and used just this system, took both of these out, and I've had zero problems. It's been very, very well behaved ever since then. And after I installed the second unit here, I've seen absolutely no problems. Now, what I did do is if you pull out this converter, if you pull out the converter that's in your particular RV, you'll notice that it'll tell you how many amps they are. Almost every RV will have one of these converters to allow you to plug into shore power and run everything. And then basically my suggestion is just get more power than that converter suggests that you need. And if you have surge items or high volume pull items like levelers, or even some of the slide outs will cause the trouble, also cause sluggishness or jerking and moving around that doesn't sound quite right. If you have that, then just overpower it a little bit, or you may have to switch to a higher quality device like I did here. Now, let's move on to the second use case, because in the second use case is probably where more of you are going to fit with the small RVs where you don't have a lot of slide outs, or you have none at all, or you're living in or you're having a van or living in a van, or you have in my case, a coffee trailer where I was attempting to run some 12 volt devices as opposed to running them directly off my solar system, because my solar system in there was a 24 volt system with two 12 volts running in parallel in series. So with those two 12 volts running in series, I ran them through the same step down device that we talked about earlier, except I ran them through a 24 DC volts down to 12 volts. Now I think technically the step down device is anywhere from 20 volts to 38, so I think it handles a 36 volt battery also, and it'll step it down to 12 volts DC. These work very, very well in this particular use case, but there is no slide outs. There was nothing more than than this thermostat, and from this thermostat was basically a temperature controlled thermostat that allowed it to run an exhaust fan. Now, the idea behind the exhaust fan is that when we parked this trailer in a fairgrounds, and we may be at a fair for, let's say we're there for 7 days. If we're there for 7 days, the last thing I want to do is pack the trailer up every single day, seal everything up, drive it home, plug it in, let it charge the batteries, do whatever, run the refrigeration, keep everything cold, and then unconnected, drive it back to the fairgrounds, set back up, and turn everything back on after I got a generator. So what I basically did is I used this solar system to run all the refrigeration overnight, and this step down was used to run this fan because the standard RV fans are 12 volts. This fan allows me to cool the to trailer if by chance the fairs is not open by the time I get back the next day. So I can basically trust that this will trigger at 91 degrees. It will cool the inside of the trailer back down to 85 degrees and then shut back off. And that will cycle on and off. This ensures that the refrigeration that's within the unit isn't so hot that it can't keep everything cold, and it's not going to draw more power than is necessary to run it. So as you can see here, there is this is a very, very good use case for most people with very small RVs, with vans, with trailers, practically almost anything that doesn't have your high draw device. These 20, 25, $30 devices here work really, really well for it. My suggestion is that you try to use them on a common circuit, and if you need more than one, you can hook them in parallel. I did try on my RV hooking 5 of them in parallel with 150 amps to see if I could get over the surge. Even 5 of them could not handle the surge. So the surge capacity on these is terrible, but the ability to supply enough power to run loads like lights and stuff like that was just fantastic. They're cheap. They're very low maintenance. The power loss was very little. It didn't cause too much trouble at all, and they're easy to hook up and maintain. There's basically just a plus and a minus coming in from the high power side, and a plus or a minus coming off of the low power side, and that's it. That was basically the 2 use cases that allowed me to eliminate all 12 volt batteries from the systems that I have and only use the 24 volt battery that's here, or to use the 48 volt battery that's in the RV. I hope those use cases are helpful to you, and if you have questions, please feel free to post them down in the comments. I'll be glad to answer them and get you whatever answers I can. And that said, this basically was the 2 use cases that will help you eliminate your 12 volt battery from 24 and 48 volt solar systems. I use the Orion TR48 1230 amp. I use the regular step down device here. Both of these are practical experiences. And if you're interested in more videos like this, there's one playing right up there. Click on it now before the timer runs out, and it should be very helpful for you in hooking up your solar system in your mobile or in your fixed location if you've got a solar shed or a home solar unit also. Thanks again, and to my subscribers, I sincerely thank you, and to my future subscribers, welcome. Hope to see you again on the next video.